this as an example, which has a resistance of 1 ohm, then 5 ohms, then 4, 2, and another, uh, 1 ohm and 5 ohm, and then 4 ohm. So let's go into this. Step 1. To select a reference node and label the node voltages. So we should first select the reference node and then label the node voltages. And by applying Kirchhoff's current law to all nodes, we should equate that, and by equating that we'll get V1, V2, and V3, which he asked in the question. And then to find the required quantities, like which quantities we are after applying Kirchhoff's voltage law in the above loop, we'll get this as a sum, by which we are taking only in this dotted region point, especially in that dotted region point. And it's about nodal analysis. And now we enter into mesh analysis. So mesh analysis is the method in which the current flowing through a planar circuit is calculated. And like a planar circuit is defined as the circuit that are drawn on the plane surface in which there are no wires crossing each other. Therefore, a mesh analysis can also be known as loop analysis or mesh current analysis. And important thing is a branch. So what is branch? Branch is defined as the path that connects between two nodes such that it contains a circuit element. If the branch belongs to only one mesh, then the branch current and the mesh current will be equal to each other, and in some cases it will be similar to each other, like approximately equal. Then let's understand mesh analysis briefly with a diagram. The below diagram is a circuit with mesh current labeled as I1, I2, and I3, and the arrow represents the direction of the mesh current here. And let's see about that. For example, in a given circuit, 90 volts is the battery, and 5 amperes is the current source, and 3 resistors are 9, 6, and 8 ohms. So using mesh analysis, determine the current across each resistor and potential difference. Let's see into this. So we should first determine the ground as shown in the figure, and then let assume the potentials like VA, VB, and VC as shown in the figure. Then after assuming that, let let I1, I2 be the current flowing through the two loops in the clockwise direction as shown here and in this mesh and here. Now by applying the KVL law, we can equate